The Shenzhou 19 mission isn't just another milestone for China's space program, it's a glimpse into the future of human space habitation. Over the past 150 days, 3 astronauts aboard the Tiangong Space Station have conducted some of the most advanced experiments in space neuroscience, medical science, engineering, and ergonomic design. In this video, we're diving into how Shenzhou 19 turned a space station into a human laboratory, what the findings reveal about cognition in zero gravity, and how China is preparing for deeper missions across the solar system. Living in orbit isn't just about floating through airlocks, it's a constant interaction between the human body, mind, and machine. During their 5-month stay aboard the Tiangong Space Station, the Shenzhou 19 crew, Cai Xuzhe, Lingdong, and Wang Haoze conducted an in-depth study into the daily livability of life in microgravity. Their work is now shaping the very future of spacecraft design. The crew didn't merely adapt to their environment, they documented it. Using structured video logs and comprehensive questionnaires, they assessed how interior layouts, tool placement, and equipment design influence their mobility, comfort, and cognitive load. These aren't abstract surveys, they're the foundation for transforming space modules into livable, human-centered environments. Whether it's the angle of a workstation screen or the location of emergency handles, every detail was scrutinized for usability and fatigue. Beyond comfort, this study tackled how astronauts interact with onboard systems. Real-time feedback was gathered on how astronauts operated various digital interfaces and hardware under microgravity conditions. How fast did systems respond? Were menus intuitive? Was information overload a problem during critical operations? These feedback loops now allow engineers back on Earth to iterate on designs that reduce astronaut error and mental strain, factors that become exponentially more important during long-haul missions to the Moon or Mars. This marks a major philosophical shift. For decades, spacecraft were built around engineering constraints. Now, Shenzhou 19 proves that spacecraft must also be designed around human needs. What's groundbreaking is that China is methodically collecting first-hand ergonomic and behavioral data to shape not just current spacecraft but also future off-world habitats. Think lunar bases with customizable interiors or Mars outposts that adapt based on crew performance data. As a preview of what's coming next, this mission sets the standard for upcoming Chinese missions like Shenzhou 20 and 21. One of the most ambitious aspects of Shenzhou 19 wasn't mechanical or environmental, it was neurological. For the first time in China's space program, astronauts conducted deep brainwave research aimed at decoding how the brain functions when gravity is no longer part of the equation. What happens when your up is down, and your motion has no resistance? The answer might just reshape astronaut training, space medicine, and even neuroscience on Earth. Cai, Song, and Wang used electroencephalogram headsets to monitor brainwave activity while performing routine tasks and cognitive challenges. This wasn't superficial tracking. It was a controlled investigation into how spatial awareness, coordination, and decision-making are altered by microgravity. By capturing neural data during these tasks, the astronauts provided researchers on the ground with a living map of cognitive adaptation in space. The experiment also included a futuristic twist, brainwave music intervention. Using synchronized soundscapes tailored to the astronauts' EEG patterns, researchers tested whether music could regulate brain states during stress or cognitive fatigue. The goal? To see if custom audio could enhance mental clarity, stabilize emotional responses, and maintain focus during high-stakes operations. This isn't sci-fi, it's practical. Long-duration space missions place extreme pressure on cognitive performance. One slip in judgment or attention can jeopardize months of progress or even lives. If tools like brainwave-based audio therapy can be developed, they could become essential aids for astronaut well-being, especially during deep space travel with long periods of isolation or minimal real-time communication with Earth. Shenzhou 19 also gathered extensive physical health metrics, ensuring every neurological reading was understood within the full context of the astronaut's biological state. Cardiovascular readings, lung performance, and blood pressure were constantly tracked, not just to ensure crew safety, but to map how physical health impacts mental performance in microgravity. These findings aren't just for space. They could be used to develop better neurotherapies for stress-related disorders, cognitive decline, and even virtual reality training programs on Earth. While the human side of Shenzhou 19 drew headlines, the engineering side was equally groundbreaking, especially the work done to validate future deep space systems. One of the most significant experiments revolved around the reverse Brayton cryocooling system, an advanced thermal control technology that could become a standard in future interplanetary missions. Let's break it down. Space is a vacuum, which means it doesn't transfer heat well. So, when spacecraft systems generate internal heat from instruments, computers, or even human bodies, it has nowhere to go. This creates a major risk of overheating. The reverse Brayton system uses ultra-high-speed gas bearings to cool down components efficiently, and unlike traditional systems, it operates without the friction that causes wear over time. Shenzhou 19 tested components of this system directly inside Tiangong's payload cabin. This technology isn't just about keeping astronauts cool. It's essential for running advanced telescopes, nuclear batteries, and high-sensitivity equipment in environments like the Moon's surface or Martian orbit, where temperature control could mean the difference between mission success or failure. Beyond thermal control, the Shenzhou 19 mission carried out a wide range of microgravity materials science experiments. These included swapping out fluid dynamics samples and high-temperature alloys inside specialized racks. The experiments focused on how heat transfer, crystallization, and fluid behavior differ in zero-gravity data that's vital for designing new materials, space-based manufacturing systems, and even medical applications like drug crystallization in orbit. The crew also managed vacuum pumping and exhaust operations, tasks often overlooked but critical for testing pressure-dependent equipment and environmental reliability. By simulating pressure transitions and monitoring outgassing behavior, engineers can model how systems will respond in hostile environments, including deep space vacuum or atmospheric re-entry. Not to be missed, the team carried out detailed environmental monitoring, including airflow speed, ambient temperature, and air purity levels. These metrics are essential for sustaining long-term missions, especially when regenerative life support systems must be optimized and balanced without constant Earth resupply. All these components point to one goal: deep space readiness. Whether it's cooling a lunar observatory, refining alloys for Mars habitats, or manufacturing sensitive devices in orbit, the engineering backbone built on Shenzhou 19's results is preparing China for the leap from low Earth orbit to planetary exploration. Shenzhou 19 didn't just orbit Earth, it set the stage for the future of human space exploration. By exploring how the brain adapts in zero gravity, advancing deep space cooling tech, and rethinking spacecraft as livable habitats, this mission has quietly shaped tomorrow's off-world ambitions. Every finding from astronauts Cai Xuzhe, Lingdong, and Wang Haoze now feeds into a larger vision, not only for China's next missions, but for humanity's journey beyond Earth. As new crews prepare to launch, Shenzhou 19 stands as a crucial milestone. The question now is, how far are we willing to go? If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, SpaceEyeNews.com. Thank you for watching, and see you next time.